Hello. Now I've just given you an egg. And you might be wondering, why has Kieran just given me an egg? It's a perfectly valid question. But I'm going to tell you why. But first, I want you to name your egg. I'm going to give you 10 seconds to name your egg. So you better think quickly. Ready? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Does everyone have a name for their egg? Good. Now that you've become emotionally attached to your egg, I'm going to take your egg in 1 week and I'm going to throw it out of my window, which is 21.15 feet off the ground. Also, for you who use meters, it's approximately 6.4 meters off the ground. If I was to take your egg as it is and throw it off out of my window, it would disintegrate upon impact with the ground. So I want you to build a device that goes on your egg that makes it so that your egg can survive a fall from 21.15 feet in the air. And you might be wondering, how do I know that that is 21.15 feet in the air? And you might think, well, that's an obvious question. You probably just tossed a ruler down or something. But actually, no. No. I would much rather use the laws of physics to determine how high up that window is. And so, in the good way of doing science, I have decided that I measured the distance from that window to the ground using a rock and a watch. And you might be thinking, why? Well, let's go inside and I'm going to tell you why. Oh, there you are. Right. So I want to figure out how far down the ground is from my window. I want to figure out the height of my window. But I don't have a ruler long enough. So that's okay, because I do know of an equation. So I have an equation here. I wrote it down. And it's 16t is equal to h. Now t in this is the time it takes for an object to fall due to gravity. And h is the height in feet. So if I take 16 times the time it takes for this rock to fall and hit the ground, then I can get my height in feet. I can also do another equation and I can go 1/2 times the acceleration due to gravity, which is approximately 9.81 meters per second squared. And I multiply that by time squared. And time squared is, for example, in this case, it probably takes approximately 1.33 seconds for the rock to fall and hit the ground. So that would just multiply, I would just multiply 1.33 by itself. So it would be 1.33 times 1.33. And that would give me a number. And that would be equal to S. And S in this case is the height of the window to the ground in meters, which is grand. Now I can also just use this easy equation, find the feet, and I can just convert it into meters. Okay? And all I would do to do that is I would divide it by 3.28, and that gets me my meters. Okay? So let me show you what that looks like. Right, so what I do is I open my window, I take my rock. Ooh, safety first. Glasses on. Careful, we don't want to rock to the eye. So I take my rock, I have a little grabber stick, because there's a bit of a lip, so I can't quite get a straight line to the ground, so I need a little hand. So, put my rock in this grabber. That's great. I set the time, I set a stopwatch on my watch, and then I do this. Grand. so I've run that experiment 5 times, and here's my results. I ran it 5 times because an experiment should always be repeatable. It's not really science if you don't make it repeatable. So I got a variety of results because I'm human, and it takes me a certain amount of time to realize that I've dropped the rock and that the rock has hit the ground, and therefore there's a certain margin of error, and that time changes. So I have a variety of times. That doesn't mean that it took a variety of times for the rock to hit the ground. Each rock was exactly the same time. And that's because each rock has a different weight, but that doesn't come into effect until it reaches its terminal velocity, which you don't need to know about. It's not that high. And so that gave me a range of, let me do the math, 22.75 feet, and also I got a 19.04. So that's obviously a big difference between the two. So what I did was I added all of them together. I divided them by how many experiments I did, in this case 5, and I got 21.15 feet as the distance from the window to the ground. And if I divide that by 3.28, I get 6.45 meters for you folk that don't understand feet. And then you should always check your result with another method. So the other method I can do that I did was I threw a rope out of the window, and I had Nana put her thumb on the ground and on where the string was, and then I measured the distance. When I took the string down, I measured the distance of the string, and that turned out to be 21.25 feet, which means I was very close. I was only 0.01 away from the right answer, or in meters, I was only 0.03 meters away from the correct answer. So, in other words, my math checks out. Right, so now I'm going to teach you everything you need to know about how to make your egg survive the drop from my window. So, as you can see here, we have potential energy, which is the energy related to height. And we have kinetic energy over here, which is the energy related to speed. And here we have your binding energy. So this is the energy that is holding the egg together. So the energy that makes this an egg, essentially. And so when the egg is on the table here, you see it has no height. There's no space between the table and the egg. Therefore, it has 0 potential energy, right? And it's also not moving. Therefore, there is no kinetic energy because it doesn't have any speed associated with the egg. Now, when I begin to pick this egg up, it begins to gain potential energy because it has more height or more distance between the egg and the table. And the further I go, the more and more potential energy it gets until I get to the top. So when your egg is about to be thrown out the window, it will have this amount of potential energy. And when I release that egg, your egg is going to begin falling, so it's going to begin speeding up, and it's going to begin getting closer to the ground, so the distance is going to shrink the ground. And so as it falls, it speeds up, so it gets energy from the potential because it's decreasing its height, and it converts it into kinetic energy. And as the egg falls faster and faster, it gets more and more kinetic energy until the moment that the egg is about to hit the ground. At that point, there is no potential energy because the egg has no distance between the table, in this case, and the egg. And it has a huge amount of kinetic energy because the egg is traveling very quickly at the table. So what you want to do is you want to decrease this kinetic energy because, as you can see, the kinetic energy is higher than this binding energy. which is represented by this broom. And so essentially, when this egg falls out of the window, it will explode. It will paint the walls because the kinetic energy is significantly higher than the binding energy. Okay? So how can we decrease the kinetic energy? Well, I'll tell you how. So first thing you can do is, it's related to speed, so you can slow the egg down. So if you slow the egg down, you are taking away energy from the kinetic energy, from its kinetic energy. So therefore, it's slow enough so that when it hits the ground, example, if I lower the egg to the ground, it doesn't break because its kinetic energy is very low, and it's lower than the binding energy of the egg. Right? And the other thing you can do is, if you think about an airbag, so you're gonna, right? So what does an airbag do? It inflates, and when you get in a car accident, it slows. Not only slows your head, but it also extends the amount of time that your head is in contact with the airbag. So what does that look like? That means it looks like you have your kinetic energy, and you have an airbag. There's more time that it takes your head to slow down, so there's more time that your head loses energy over time. So it looks like this. So you're going along, you crash, airbag deploys, your head starts to hit the airbag, keeps hitting the airbag, stops hitting the airbag, and look, your head is still in one piece because the kinetic energy of your head was below the binding energy of your head. So, for example, your egg, if you manage to increase the amount of time that the egg loses energy, you will keep the same amount of energy below this binding energy. Right? So two things that you need to remember. You can either slow the egg down, which takes away from the potential energy of the egg, because, it takes away from the kinetic energy of the egg because it's going slower, or you can extend the amount of time that it takes for the egg to lose all of the kinetic energy in the form of work. We won't talk about work because you don't need to know about work. Okay? So now I'm going to do a few calculations. So we'll go back inside and we'll determine how much kinetic energy this egg is going to experience if I was to drop it out of my window, and also how much binding energy holds this very egg together. I'll see you inside. Right, so now we're back inside, and I want to figure out how much kinetic energy this egg is going to have when it hits the ground, right? So, go over here to this board. So, kinetic energy, as we just talked about, is, the equation is 1/2 mass times the speed squared, also known as the velocity squared. And so, I need to go and weigh the egg. So, let's go and do that now. Right, now that I've weighed the egg, I found that the egg is 53 grams, which is probably a reasonable weight for an egg. And so now we need to figure out how fast this egg is going when it hits the ground. So down here we can see I have an equation, and this is the equation for speed, or as we call it in the scientific community, velocity. So that is calculated by the change in height, so how far the egg falls over the change in time, so the amount of time it takes for the egg to hit the ground. And so if you look at it, it takes about 1 second, so 1.33 seconds for the egg to fall and hit the ground, and you put that underneath how many meters it is from the window to the ground, and we found that that was 6.48 meters. So we divide 6.48 meters by 1.33, which is number, right, which is 4.87 meters per second. So if we plug that, so we put that back into the equation here, we also put in that the egg weighed 53 grams. So this equation uses kilograms. So that means that the egg weighs 0.053 kilograms. Kilogram is 1,000 grams. So we multiply 1/2 times 0.053 kilograms times our speed, which is 4.87 meters per second, squared. So we square that, multiply 4.87 by 4.87. And that is equal to 0.63 joules. Now that doesn't sound like a huge amount. 0.63 joules. I mean, come on. But if we look at the binding energy of the egg, that binding energy is, well, it's 4.57 times 10 to the negative 19th power. And what that looks like is 19 zeros followed by 4.457 joules. So essentially, when the egg hits the ground, so at that moment that the egg hits the ground, it is going to have 1 octillion % more energy than the energy holding the eggshell together. So 1 octillion. That's 27 zeros. So it's a 1 followed by 27 zeros. So this is the amount of force, or the amount of joules, the energy, the kinetic energy of this egg when it hits the ground is going to be 1 octillion % approximately more energy than the energy holding this egg together. In other words, when I throw this egg out the window, it is going to explode. It is no longer going to be an egg. It is going to be paint. Right, so I have now given you everything you need to know to complete this challenge. We determined the height of the window using only a rock and a watch. We went through all of the physics behind an egg falling. We calculated the amount of kinetic energy that this egg will have when it hits the ground. We determined how much more energy that very kinetic energy is from the binding energy that holds this egg together. It is now up to you. You have 1 week to build a device that will keep your egg alive and in one piece when it hits the ground. There are only 2 rules. The first rule is you cannot chemically alter your egg. You cannot boil your egg, you cannot have your egg go through a chemical reaction which makes it bouncy or stronger or anything. You cannot do anything chemically to your egg. Your egg must remain exactly how I've handed it to you. The other rule, this is for the parents. You are not allowed to give your kid any ideas on a method or device that would save their egg. It must be entirely theirs. You can discuss with them how they might go about achieving this challenge. But you are not allowed to give them any ideas. I want to see what the kids can come up with. I want to see if the kids can save their egg with the knowledge that I have just given them. And with that, I'm going to give you the rules. I will take your egg in 1 week, and I will throw it out the window. And when that egg hits the ground, I will take apart your device and check your egg. The person whose egg is completely intact without any cracks will win. I'm not going to tell you what they'll win. Or what you'll win. But anyway, you have 1 week. Good luck. And may the odds be ever in your favor.